Hi, and welcome to this talk on how mutation testing can help to improve the quality of your unit tests. I'm Simon. I'm an IT consultant and open source fanatic working at InfoSupport in the Netherlands. Today, I want to talk to you about mutation testing using a demo application, which I'll now introduce. We are currently living in the future, and in the future, you are no longer buying drinks from a bartender. Instead, we have robots that are working at bars. And every table has a nice tablet where you can order some drinks. So this is what the application will look like. Currently, we only support 3 drinks: Robo Cola, Robo Beer, and Robo Wine. For now, let's start off easy with 2 colas. I can submit my order, and then I get an order overview, which contains my 2 colas. Then I can press the order button, and the robot will start to prepare my drinks and bring them to my table. But if I add an alcoholic beverage, for example, a beer and a wine, to my order, the robot will now verify my age to ensure that underage people are not allowed to buy alcohol. Well, we did not have the budget for fancy robots that can have facial recognition or anything, so we just use a simple age check, which is good enough for our case. So if I enter my age, for example, I'm 12 in this situation, then I should not be able to buy any alcohol. And if I order, I indeed get an error message. Great, only adults can buy alcohol. So that's great. Our logic is working as expected. Now, if I enter a higher age, for example, 35, and order again, my 3 drinks are coming right up. So that's the demo application. Since we're working with transactions from customers and an age check, we want to make sure our application is properly tested. And to do that, our application has unit tests. Unit tests are at the cornerstone of all automated testing that we do for projects. In most projects, you will see a lot of unit tests, a few integration tests, and perhaps some UI tests or manual tests. But in most cases, just like with a pyramid, unit tests will be the base of your application tests. And a unit test can be seen as testing a small brick of Lego. You're not testing the entire box, you're not testing the entire manufacturing process or all the instructions together to create, for example, the Millennium Falcon. No, you're simply testing one small Lego brick. Does the Lego brick have the correct color? Is it made out of plastic? Does it have 4 studs on the top and is it a square? Does it say Lego on each stud? Is Lego actually spelled in the correct order or is it spelled backwards? Things like that would be tested using a unit test. Just really small pieces of code. And if we look at our application that we saw earlier, we might have some code like this. A function is allowed to buy alcohol, which gets the customer as a parameter. And it will return true if the customer's age is at least 18. And we may have a test for Mark, who is age 24, and Mark is obviously older than 18, so he is allowed to buy alcohol. Now, if we write a lot of unit tests for our application, we want to measure the quality of those unit tests. For most projects, the answer to doing this would be code coverage. And for our demo application, we also have some awesome code coverage, without which I will now show you. Our tests can be executed from the command line using the command npm test. This will start Karma, which will open a Chrome web browser to run our tests. And it's done testing already. In our case, it executed 16 tests. During testing, it also generated a code coverage report. And this is the code coverage report. In this code coverage report, you can see that we have a 100% coverage of statements, branches, functions, lines, which means for code coverage, we have tested absolutely everything we can test. Most projects that you might see don't have 100% code coverage. And if we dive into one specific component, for example, the review order component, we can see that we also have 100% coverage in this file as well. And we can see our actual code. To the left of the code, in the green line, we can actually see how often every line of code gets executed. And for the age check below here, it actually gets executed twice. Now 100% code coverage is really fantastic. That could mean that we are done testing, but we might have a lower score. And to do that right now, I'll just redisable 2 tests that verify the age check, and run my tests again. When doing this, we will see that we no longer have a score of 100% because of the disabled tests. We will also see that the amount of successful tests has dropped from 16 to 14. And if we refresh this, we now have a score of 89% for this specific component. And we can see which pieces of code did not get executed. With a report like this, you get an idea of which pieces of code still need some testing, which is great. But when your score is 100%, it becomes a bit more difficult. For now, I'll restore the tests because we don't accidentally want to leave some tests in comments. So if we go back to how code coverage can help, well, if we just zoom into this piece of code, we yet again have the age check, and right now we only have one test. In our application we have two, but for now we have one. If we check the code coverage, what would it be? Well, in this case it would be 100% as well, because we are not testing all the possible logic in our code, since we don't have a test for someone who's younger than 18. And a developer might say, yeah, well, we're not done testing, obviously. But if we look at code coverage, it's 100%. And in this case, you can see that we need to write some tests. But our applications that we usually write are a lot more complicated than this. And it can be a lot more difficult to actually verify if we have tested everything properly. So the feeling that code coverage kind of gives me is this. All the unit tests pass, because every letter fits in the hole. But if we look closely, nothing is really right. And to help with this, we can take a look at mutation testing. Mutation testing is a method to introduce bugs in your code temporarily to test your tests. How does that work? A mutation testing framework will start off with your source code. And it's just your heavy, regular source code that's checked into master, for example. Well, nothing is wrong with it, it's still working fine. Then the mutation testing framework will come along. It will make one small change to your code. For example, changing a plus sign into a minus sign. This will usually result in a different outcome from your source code. And since the outcome of your source code has changed, you would probably have a test that fails. That's also what mutation testing looks for. It will execute your tests after introducing a mutant, and usually there are two outcomes. Either the mutant has been killed, and if it has been killed, at least one test has failed, which is great, or the mutant has survived, which is something we want to prevent. And a mutant has survived if no test fails. So, contrary to regular testing, we want tests to fail with mutation testing. Normally you want everything to pass, but right now we are actually introducing bugs to see if our tests can pick them up. A mutation testing framework will do this hundreds or thousands of times for your source code. And in the end, it will combine it all in one nice report, such as you saw with code coverage. How does that work in the code? Well, if we go back to the example of someone buying alcohol, we first had the original code, return customer.age greater than equal 18. A mutation testing framework will change the source code. It will change it to less than 18. This will flip the entire check around. Now someone who is younger than 18 can buy alcohol and all adult people cannot buy alcohol. Well, if we run our test below, the test will fail and the mutant has been killed because the test was able to detect the mutant. But if we change the code to greater than instead of greater than equal that we had originally, the test still passes and the mutant has survived. This means we either have to write another test or we have a bug in our current test. In this specific case, we can also just change the entire statement to return true, since we only have one test and we can always return true. In this case, the test still passes, obviously, and the mutant has survived. Now, there are a lot of mutations that a mutation testing framework can make. The types of mutations that can be made differ from language to language and from mutation testing framework to mutation testing framework. But here is a list of some common mutations that you might find. For example, changing the plus sign into a minus sign, or less than into greater than. And one of my favorite ones for JavaScript, the one at the bottom. In JavaScript, we can simply empty an entire function, even if it had some return statements, and just to see what it does. After mutation testing has been executed, we get a mutation score. This is the percentage of mutant that has been killed divided by the total. And this percentage can be included into your build and into SonarQube, for example. This way, you can always verify that your score is, for example, at least 70 or 80%, depending on what you want for your project. Mutation testing is available for a lot of different frameworks. Right now, I would suggest using StrykerJS for a JavaScript or TypeScript project. But you might use a different language or framework for your backend service or any other microservice in your application landscape. And here are some common frameworks that you might use. If your language is not on this list, feel free to simply Google the name of your language or framework that you're using, combined with mutation testing, and you will probably find a solution somewhere. Now, this all sounds great. We get a better indication of which parts of our code are tested, which bugs can be made without us actually knowing it in an automated way. But there must be downsides. Well, unfortunately, there are some downsides. One of the major downsides is that mutation testing is a lot slower than actually running your tests once or generating a code coverage report. Because with mutation testing, you are not simply executing your tests once. You are executing your tests hundreds of thousands or 10,000s of times, which will take a lot more time than simply executing them once to verify if everything works. Configuring a mutation testing framework can also be a bit difficult, because mutation testing frameworks will have to hook into your entire build process and your testing process in order to work, which can differ from language to language and project to project. This also makes project support an issue, especially in the JavaScript world. Luckily, we have a solution. That solution is StrykerJS, the mutation testing framework for JavaScript and related languages such as TypeScript. Its name comes from William Stryker, who is a character in the X-Men series. William Stryker really hates all the X-Men mutants and wants to kill them all. But one of his own sons is a mutant, so no matter how hard he tries, he will always be tied to the mutants, just as with Stryker. So what are some strengths of Stryker? Well, Stryker aims to be fast to run, to make sure you spend as little as time possible waiting for a mutation testing report. It does this using a variety of ways, but one that I really find interesting and cool is using code coverage. Stryker generates a code coverage report for your application to see which parts of your code gets tested by which test. Then, when making a mutant, Stryker will already know which tests have to get executed. This will cause Stryker to only run a fraction of your entire unit test suite, making it a lot faster. Stryker also aims to be able to use. For example, we have IntelliSense in our configuration file, which we'll see in a moment, and we also aim to be extendable to all projects. So let's start mutation testing. I'll go to my command line and init Stryker using Stryker init. This will start a small questionnaire. It will first ask me how to install Stryker. In my case, I want to install it using npm. Now we'll go to the npm repository and fetch the Stryker package from there and install it to my repository. And this will take just a moment. All right, so it's done. Now Stryker will continue with the rest of the questions to configure my project. The first question it will ask me if we are using one of the following presets. For example, the Angular CLI, Create React App, or Vue CLI. If we have one of these types of projects, we can use a preset configuration and continue from there. In my case, I want to use a manual configuration for this demo. The first question Stryker will ask is, do we have a specific test runner that we want to use? In my case, we are running our test using Karma. If our test runner is not on this list, you can create your own plugin to support your test runner, or you can use the command test runner. The command test runner does have a significant downside for performance, because Stryker cannot hook into all the performance optimizations it can do for the other frameworks listed here. So for now, we'll simply choose Karma. Then it will ask me if we have a specific build command that has to get executed. In our case, we don't have a build command So we'll simply select none. Next question is about reporters. In our case, the default reporters are fine. We specifically want the HTML report, which is enabled by default. We want to install these packages using npm, and I want my config file as a JSON file. If we want, we could also choose a JavaScript file. Now, with the questions done, it will start to install the required dependencies, and then we can start mutation testing. While doing this, it also generated a config file for us, which is the stryker.conf.json. This contains the config that we just selected, for example, the reporters, the tester and Karma, and also some config for Karma specifically. If we needed some more configuration for Karma, for example, our config file is somewhere else, such as in the test folder, we could set that here or override some test configuration for Karma itself. If you're using a different project, for example, the Jest, you will see some different config here, specifically for that framework. There are also some more options available, which can be seen using some autocomplete. You probably want to change the mutate property. This property contains the set of files that will be mutated by Stryker. By default, we look into your source or lib file and select all files there, which are not test files. But we may also change this to, for example, all JavaScript files in the source directory. Or perhaps we want to test one specific directory, such as my new component, and perhaps exclude something in that folder, such as do not test me.js. In this case, it will test everything in the my component folder, which is a JavaScript file, except for do not test me.js. For now, we can use a default mutate option. Because of this demo, I'm changing one more setting, which is the concurrency, which is the amount of parallel processes Stryker will use. I'll set this to 2 for now. But in most cases, you will want to use the default value. I can now start killing some mutants with the command Stryker run. This will instruct Stryker to start the mutation testing process. Stryker will detect my config file. It will find 12 of my source files, and in those files it has generated 126 mutants. Next, it will start 2 test runners, just as I said with my concurrency option. Before I actually start the mutation testing, it will do an initial test run. In this initial test run, it will see if Stryker is actually able to run the tests. In some cases, Stryker will not be able to run the tests. For example, if Stryker does not support your project, if you made an error in the configuration, or if you simply have failing tests on your main branch. Stryker will want to know about this before actually running the mutation testing. Because if a test is failing for whatever reason, well, we can't trust the results of the test if we make a mutation. So all tests have to pass before we run. Right now, it's already doing the mutation testing itself, and it's about halfway there. So in just a moment, it will be done. All right, it's almost there. Great. It is done mutation testing. In the console, we get a nice small report with the mutations that Stryker made. We can also open the HTML report to see some more information. This report looks a lot like the code coverage report that we saw earlier. We can see the total score, in our case 58%, and a score for each file. Just as with code coverage, we'll take a look at the review order component. And we can see that it has a score of 73.53%. 25 mutants have been killed and 9 survive. So we will want to target those 9 surviving mutants. If we go to the age check, right here, we can see that there was an error. And if we press the red button and back, we can see which mutation has been made. Originally, our code was customer.age greater than equal 18, and it has been mutated to customer.age greater than 18. If we press the More button below, we can see which test actually covered this mutant. In our case, there were 2 tests. So we will want to improve these tests. If we go to the code and to the tests, we see we have a test for someone aged 24 and aged 12. Since the age tag is for someone aged 18, we should have a user aged 18 who is allowed to buy alcohol, and someone aged 17 who is not allowed to buy alcohol. This way, we are simply testing the edge case, which is what we want to do to make sure we don't have any mutations in our code. Now, if we look at the rest of the code, we also see some errors in the constructor. For example, in the number of drinks property, which is created using the order. 2 mutations have survived in this piece of code. One actually removed the entire function in the reduce function, and it was covered by 5 tests. The other one changed the plus sign into a minus sign, and this one was covered by 1 test. So this is a test we will want to focus on to improve. In our case, there is a test which should check the constructor to set the order, number of drinks, and age check properties. Well, the order is properly tested, but the number of drinks has 2 surviving mutants, and the age check has 1 surviving mutant. So if we go back to our tests, we can actually find the test. And what the test currently does is the following. It adds 2 items to our order, a robo beer and a robo wine. In total, there are 2 different types of drinks, but 3 drinks have been bought together because 2 beers have been bought and 1 wine. So we have to add a check because currently we're only checking the order. So we can say expect system_test.number of drinks to be 3 because of the 2 beers and 1 wine. Now we also have to test the age check. And I believe it should be true. Let's take a look at the code. The age check will be true if at least 1 of the drinks in our order is alcoholic. Well, in this case, we have some beer and wine, so we have some alcoholic beverages. So I think this should be right. Normally, I would write some more tests for the different cases, for example, with more drinks, less drinks, and an age check which would be false. For now, for the demo, I'll leave it at this. Before starting mutation testing, I quickly want to see if our tests are currently succeeding. The fastest way to do this, because we have very fast tests, would be using npm test. And we can see that actually one of our tests is failing. It expected false to be true on line 24 of the review order component.spec.js. Well, that's the age check. Now that's a bit strange, but I can explain it. The age check verifies if our drinks are alcoholic. But since we're using a unit test, we are manually pushing our orders into the current order. We are not actually using the UI which sets up the correct data. So we are not setting the is alcoholic property. If we go to the code, I'll copy the name if that works. No, is alcoholic. True. And both beer and wine are alcoholic beverages in our system. So this should be marked as such. Now let's run the tests again. All right, now all our tests are passing. We still have 16 tests, since we did not add or remove any tests. We only expanded on and fixed existing tests. Now let's run Stryker again. This time, Stryker will still find the exact same amount of mutants, and the same changes will be made. Since our source code has not changed since the last time we ran mutation testing. We only changed our test files. So the result might be different, but the mutations and the mutations that have been made are the same, since mutation testing is done in your source code. Yet again, mutation testing will take just a minute for our project, and it will be done soon. Right, so it's already about halfway there. And when it's done, I would expect our mutation testing score to be higher than it was before. If we look at the previous score, for our file, it's 73.53%. So this should be higher since we are now killing more mutants. All right, and we're done. Now we can refresh this report, and we see that here we have a score of 85%. So we have about a 12% increase in our score. If we now look at the code, the number of drinks no longer has any surviving mutants. Neither does the age check. Same goes for the check below, if a customer is allowed to buy alcohol. We are now killing each and every mutant in these pieces of code. There are still some things we have to test, but let's do that another time. We can still find the mutants that have been killed if we enable them. And we can see in the is allowed to buy alcohol, there are 4 mutants that have been made. We can also see which ones of the tests covered it, which mutant actually failed in the test, and which error was emitted. And if we look at the number of drinks, we have the mutant that changed the plus sign into a minus sign. There is one test that covered it, that one test also killed it, and the error is expected -3 to be 3, which was the exact error that the test runner gave us. And if we go back to all files, we see that our general score also improved. But there is still a lot of room for improvement in our source code, in our tests. But let's do that another time. To recap the mutation testing that we saw today, please don't just trust code coverage. Code coverage will give you an idea of which pieces of code are tested and which pieces are not tested. The higher your code coverage is, the less likely it is to tell you something about the quality of your unit tests. If you have a code coverage score of about 20 or 30%, you can be fairly certain that you don't have good tests, since you are only testing a fraction of your source code. If your code is 80, 90, or 100%, it becomes a lot more difficult to actually say something about the quality of your tests. If you want to know the quality and effectiveness of your tests, please consider using mutation testing, because with mutation testing, you actually introduce bugs in your code to verify if your code works and if your tests are able to detect them. If you want to use mutation testing for JavaScript or TypeScript, I would recommend using StrykerJS. With that, I would like to thank you for attending. If you want to learn more about Stryker, please check out our site, which also includes our example. If you want to take a look at these slides, they are available on my GitHub. And if you have any more questions about Stryker, feel free to hit us up on Twitter @Stryker_mutator. Thank you and have a great conference.